Hi, I'm Tom Mihawk, and welcome back to my personal finance course. This segment is on time value of money. It's critical to begin thinking in a personal finance environment about things being of different values today versus the future, or planning for a future event like retirement or college, and bringing back to the present how you would have to prepare for that or what the cost might be today. Similarly, we'll talk in a future chapter about the impact of taxes and how, you need to make $100,000 to be able to afford a $70,000 college tuition as an example after tax. And so it's key to begin thinking in these terms. If you're here, by the way, as a student of mine, welcome. Glad to have you. If you're here from the outside, from the web or YouTube or something, welcome. Glad to have you too. Things change in value over time. What it costs to buy a home in Florida today, or Scottsdale, or the New Jersey Shore, or the California coast to retire is very different from what it'll be in 30 years or 40 years. And so being able to calculate those differences is really important and be able to plan for them. Assets earn interest over time as compensation for investing. When you invest in a stock, as an example, other things too, but a stock, when you invest in a stock, you expect over time to have the stock price go up, an increase in a capital gain, or to receive dividend payments or something like that, right? Expenses get costlier over time due to inflation. Think about basic things like eggs, milk, groceries, which you pay for milk today. I don't know what it is, but let's say it's $3.50 for, a half gallon of milk. In 5 years, it's going to be $4.50 or something like that, right? The cost of a car, the cost of college tuition, the cost of retirement, right? And these things change over time due to inflation, which is generally present in a healthy economy. Now, in a healthy economy, prices go up reasonably over time. In an inflationary, a highly inflationary, poorly run economy, prices overinflate like this. And you don't want prices in general to go down because you want industry to be able to sell things for more in general. Now, we all see TVs and computers and other things go down in price over time, but it's made up for by selling more of them and bringing out new products with better capabilities that are still high priced. And in general, the price goes up. You must have a way to estimate the future values and costs, determine which financial choice to make now versus the future, whether it's better to accept a single amount or a stream of income. A stream of equal payments is called an annuity, or if you receive a stream of equal payments called an annuity, now versus the future. So it's really important to understand these time value of money concepts. So think of it like this. This is some simple background. Let's say you're earning 10% interest annually for 1 year. So what that means is not redundant. What it means is you're getting a 10% annual interest rate and you're getting it for 1 year. If it was 12% for 1 year, but you get it for 3 years, 12% annually, but for 3 years, that's different. So this is a 10% annual rate of interest, but you're getting it for 1 year. On $100, that would be $10, right? Easy enough. And the total at the year end, you'd have your 100 that you started with, plus the $10 that you earned with your 10% interest, or $110. Mathematically, the way we calculate this would be to say 100 times 1, or the quantity, 1 plus the interest rate, or 10%, is equal to $210. 100 is the present value times the quantity 1 plus the interest rate equals the future value. A little bit foreshadowing there, right? So what if you earned 10% interest annually, but for 2 years this time? So in the first year, we just did it, right? $100 times 10%, $110 at the end of the year. Take your 110 times 10% for the second year, and you now have 121, right? And the math for that would be $100 times the quantity, 1 plus the interest rate, that's for the first year, times the quantity, 1 plus the interest rate, that's for the second year. That equals your original $100 times 1 plus the interest rate squared. Not that confusing. Stay with me. The total of that is equal to $121. Just what we did a moment ago. So the present value equation for this is the future value is equal to the present value times the quantity, 1 plus the interest rate, to the power of the number of periods. In the example that we just did, 2 periods, so it's squared to the second power. Or another way you might look at it is to say the present value times 1 plus the interest rate to the number of periods power, 2, 3, 4, whatever it is equal to the future value. You do this stuff every day. Not that complex. Stay with it. Now, when I draw this on the board, when I'm teaching face-to-face, this is the way I draw it. I say future value is equal to present value times the quantity, 1 plus the interest rate to the n power, the number of periods, 2, 3, whatever, however number of periods there are. Just using simple math, we can rearrange this and say the present value is equal to the future value over the quantity, 1 plus the interest rate to the n number of periods. And the way I draw this to show people sort of graphically how this works, I'm an engineer undergrad. I think in pictures sometimes. I think of balance sheets, believe it or not, graphically in my brain. So you have the present value today. Let's see, let me do this way. Present value today, PV, future value, FV, and in between, the way we get from present value to future value is by compounding for a number of periods. That would be months, quarters, years, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, however many, 30, 36, 360 if it's a 30-year mortgage, for example, at some rate of return. So present value gets to be a future value by compounding for a number of periods at some rate of return. Or we could say a future value over here, we can get to the present value by multiplying by 1 plus the interest rate, 1 plus the interest rate to the number of periods. Periods are in between, interest rate takes place in between. The values can be a single amount or a stream of cash flows. Here we've got a present, and a future value. We could also have a stream that represents a present value or a stream that represents a future value. We do problems and it'll become much more apparent to you. The problems aren't part of this video, but in the course we do problems and it'll become much more apparent to you what we mean by this. Compounding periods are typically annual, 1 time per year, but sometimes they're quarterly, 4 times, or sometimes they're monthly, 12 times per year. The greater number of compounding periods causes greater value. So if you have a 10% annual rate of return, but it compounds monthly versus annually, you have a greater value for compounding monthly. Similarly, if you have a credit card that you're paying 15% interest rate on and it compounds daily versus compounding monthly, you'll owe more interest, even though the rates are still 15% annually, you'll owe more interest when it compounds daily than when it compounds monthly. Very key to know. When I learned this as an engineer, I had no clue. I learned this in I think it was called engineering economics, and we used a book with charts and tables. I had no clue how it worked. And I was an engineer. I mean, I understood formulas and numbers and didn't get time value of money. This is why I recommend using a calculator. And I will certainly go over this in the course. I may produce a video about this. We'll see, depending on time. But I use this is the HP12C. It's a terrific device for doing time value of money calculations. Other calculators work too, but this one is a great one to learn. And it's why I make sure that in my classes we do it, because it really reconfirms or reinforces the concepts in time value of money calculations. The rule of 72 is really key to know. It's a kind of, you lick your thumb, stick it up in the air. It's a rule of thumb for how long it takes money to double. When you don't have a calculator, rule of 72 is a great way to do it. If you have a 6% rate of return, money doubles in 12 years. 72 divided by 6. Similarly, if you want money to double in 6 years, you need to earn 12%, 72 divided by 6. At a 10% rate, money doubles in 7.2 years, right? 7.2 divided by 10. And if you want money to double in 10 years, you need to earn 7.2%, 72 divided by 10. Rule of 72 is a great rule of thumb. If you don't have your calculator and you have to do some quick math to calculate a rate of return, the rule of 72 is a great way to be able to do it. This has been the segment on time value of money. We'll have problems in the course to work on, a few other things that we'll do. The quizzes will reinforce this. You'll see this on your quizzes. But this is a great introduction to time value of money. Thanks for watching, and thanks for taking this course.